Hello dear students, I welcome you to this lecture number 2nd. It is lecture number 2nd on differential calculus course first that we are starting. Last time we have given you just introduction what we have to do in this differential calculus. Today I want to have the lecture number 2. I will first give you the language. I have already told you that we will be having a language in this differential calculus. I will write the first thing. It is language of differential calculus. What is that? What is the language of this differential calculus? It is the differentiation. Differentiation. You have to review and revise what you did in your differentiation. It is very important when you know the fundamental basic formulae in this differential calculus differentiation, then you can go ahead. You have, I will start from the very simple results. For example, you have if y is x raised to power n. Let me say you write here that n belongs to Q. It is the rational number. It can be positive integer, negative integer. Then you have dy by dx. Dy by dx you write it is n times x raised to power n minus 1. If you again differentiate this, what is this? d2y. Sometimes you write it y1, first derivative. If you again differentiate y2, what is that? d2y dx square. You can write it n into n minus 1, then x raised to power n minus 2, and so on. Similarly, if you have y is equal to ax plus b raised to power mc, this implies your first derivative y1, which is also dy by dx. I am just bringing something from unconscious level to the conscious level. I know you have already done it. Without this, you could not pass your 12th class. You have done these things. I want to just bring your this concepts that you have already done from unconscious to the conscious level. Then when we differentiate this, what is this? This is m down, then it is ax plus b raised to power m minus 1, then internal derivative of ax plus b, you know it is a internal derivative of ax plus b. That means your y1 is m a into ax plus b raised to power m minus 1. If you differentiate again this setup, if you differentiate again, what you get? It is y2, that is also d2y dx square, you may say. It is your m, this m minus 1 down, internal derivative of ax plus b, that is a, it will become this, it will make it this a square. This is ax plus b raised to power m minus 2. Similarly, you can go for third derivative, fourth derivative. This is actually what we are giving the successive differentiation. Successive differentiation means how we differentiate the function one after the other. It is just giving you the review of this. So I have mentioned here language of this differential calculus so that you will revise your basic concepts in differentiation. You have also done the derivative of, suppose you have y is equal to log of fx, any function fx. We take here Napierian logarithm, natural logarithm. It is to the base e. If it is not base e, we have to bring it is base e, then we differentiate. Because you have done in your previous classes this differentiation of log x to the base e. If base was not e, you could change the base e, then differentiate. It is Napierian logarithm, or you may say natural logarithm. Well, when you differentiate this, how we differentiate this? You will write it is dy by dx. It is 1 upon the function, 1 by fx. Okay, then derivative of fx here, it is f dash x. Suppose you have y is equal to log of tan x. It is understood base is e. Then you will find out dy by dx. What is that? 1 by tan x. Okay, then here you will write in the numerator derivative of tan with respect to x. Remember, it is sec square. It is sec square x. 2 it is dy by dx. Similarly, if you have, say, y is equal to under root of fx, this is radical. Remember these formulae. Differentiation of the radical function. How you go? You write dy by dx, radical. It is 1 by twice the radical fx. 1 by twice what it is. Then derivative of fx in the numerator. It is f dash x. How you apply it? Suppose somewhere you meet, you may come across the situation like this. Your y is under root of 1 minus x square. You want to directly differentiate this. When you differentiate it, what you get? It is your dy by dx is 1 by twice what the radical is, along with its root. 1 by twice under root of this. Then in the numerator you will write derivative of 1 minus x square with respect to x. It is this f dash x. Derivative of the function under radical, which is derivative, is to be written then in the numerator. Then what is this? It is minus 2x by 2 times under root of 1 minus x square. This way we go for the difference. It's something basic. Then you will this revised derivative of sine is cos, derivative of cos is minus sine, derivative of tan is x square, derivative of sec is this sec x tan x so on and so forth. We will come across such these derivatives in the meantime, and we go for successive differentiation. And I take it for granted that you have revised this last time. I have told you that you should revise this differentiation concepts. Now in between the problems, in between the results, because we have full course on differentiation, I will be giving you side by side the formulae. I have picked up some important problems from your text or from your engineering book, some important on this is successive differentiation. These problems are on successive differentiation. This is the first problem that I want to share with you. It is this solution, so that you will come to know how we go. This is the first problem. This is second one. This I will name third. This is your fourth. This is fifth. It may not be visible to you. I will write them again here. First, it is y is alpha times alpha beta are here constants. Y is alpha e raised for mx plus beta e raised for nx. Then prove that this is this. You see here, it is second derivative is involved, d2. How we go? Very simple. You have done such problems in your 12th class also, but it will just give you a sort of revision. Let me have the solution of this. Solution. It is also the question on successive differentiation. Suppose you are given y is alpha e raised to power mx plus beta e raised to power nx. You have to prove this thing, d2 by dx square plus minus m plus n dy by dx. First step is I will differentiate this with respect to x. Differentiate this function with respect to x. Note that this y is your dependent variable, and it is your independent variable. When you find out dy by dx, y is dependent variable, x is independent variable. Means we are finding out the rate of change of dependent variable with respect to its independent variable, as you did in your 12th class. Okay, this is dy by dx is equal to alpha is constant here. Exponential function. What is derivative of exponential function? This is the first beginning. I will write here what is this. Exponential function as it is. Differentiation of power of the exponential function with respect to x, it is m. Then log of e to the base e, because here base e, log e, this log to the base e. Similarly, you have beta, exponential function, e raised power nx as it is. Differentiation of power, it is n. Then log of e to the base e, it is 1. So you are getting dy by dx is your alpha, m alpha, e raised power mx. Here you are getting plus n beta, e raised power nx. Name this second. Now differentiate again. Let us differentiate this again. Differentiate again with respect to x. When you differentiate this again with respect to x as per the requirement, because we need here d2y by dx square, second order derivative. When you differentiate this, what is this? It is d2y dx square is equal. Similarly, this is constant, derivative of this is e raised power mx, as it is differentiation of power, that is m log of e to the base is 1. So I will write it m square alpha e raised to power mx. Clear? I will write similarly derivative of this n square beta e raised power nx. This is my equation third. Now I can prove it directly, or I can use the left hand side. Now you can use the left hand side. Left hand side of the required result is, what is that? It is d2y dx square minus m plus n dy by dx plus mny. I have to prove it is 0. How we go? d2, it is this d2, use this. It is m square alpha e raised to power mx plus n square beta e raised to power nx, then minus m plus n. What is the value of dy by dx? It is here. m alpha e raised to power mx plus n beta e raised to power nx, then plus mn into y. What is your y? It is alpha e raised to power mx plus beta e raised to power nx. Let me simplify now this. Can I get this equal to 0? I want to prove that it is 0. You see how we go. This is your m square alpha e raised to power mx plus n square beta e raised to power nx, then multiply by this m first. This is minus m square alpha e raised to power mx minus n square beta e raised to, it is mn beta, this will be minus mn beta. When we multiply by m, we multiply first by this m square, then this is this mn minus mn beta e raised to power nx, then go by multiplying this n, it is minus mn alpha e raised to power mx, then minus n square beta e raised to power nx, then plus mn alpha e raised to power mx plus mn beta e raised to power nx. You see how you go. This gets cancelled. M square alpha e raised power mx. This is your m square alpha e raised power mx. This is your n square beta. This goes with mn beta. With this is with this. This is 0 is equal to right hand side. Very simple problem. You can go this way. So this way, this application I have taken on this successive differentiation. This is done. Okay. These are some problems on successive differentiation. Then we have to go for another derivative. How we find out another derivative, and we will then reach the Leibniz theorem. Well, let us see. Here is the problem. You are given to. It is if y is sine of sine x. You have to prove d2y dx square plus dy by dx tan x plus y cos square x is 0. How we go? Name this first. Let us differentiate this. How we differentiate with respect to x. When you differentiate with respect to x, what you get? dy by dx equal derivative of sine. Sine of this, it is derivative of sine is cos of sine x. The internal or derivative of angle, derivative of sine x is cos x. So you get what? dy by dx is cos x into cos of sin x. This is second equation. Okay. Now we differentiate this again. Differentiate again with respect to x. We have to go now product rule. It is d2y by dx square. Product rule, you know. Differentiate any function out of 2. You can differentiate this. First is this. Differentiate this as this is derivative of cos. It is minus sin x. Okay. This is cos of sin x. Second function as it is. Then plus first function. It is cos x as it is. Derivative of second. Derivative of cos is minus sin x. Sin of sin x. Then internal derivative of angle sin x, it is cos x. Okay, derivative of this as it is, then plus this as it is, derivative of this. It is the product rule of differentiation. You did it. It is d2y dx square is, we can write it is minus sin x cos of sin x. It is minus cos square x, this cos x, this cos x, cos square x into sin of sin x. You see how we go now. Now your sin of sin x is actually y first. Sin of sin x, it is y. Replace by first, it is y. Now here from second we have cos of sin x. I will write this cos of sin x. Cos of sin x will be 1 by cos x dy by dx. I will write here by second. By second I will get cos of sin x will be now 1 by cos x dy by dx. I will replace this cos of sin x by cos of sin x is 1 by cos x dy by dx. Then this sin of sin x is by first, it is y, and using y, using first and second. We are using both things. Then it is d2y by dx square is minus sin x into the value of this is here 1 by cos x dy by dx, then minus cos square x as it is y. Now you see what it is. It is d2y by dx square is equal to minus sin by cos, tan x, it is minus tan x dy by dx minus it is y cos square x. Now you can take these to this left side. This is d2y dx square plus tan x dy by dx plus y cos square x is equal to 0. It is this that you wanted to prove. You have proved this also. This was your application number 2 you did. It is just a review of your differentiation. Simultaneously we are focusing on successive differentiation and your differentiation gets revised. Both things. Let me take one more problem. What is that? It is your x is, if x is given by, it is a plus bt e raised to power minus nt. You are asked to show that d2x by dt square plus 2n dx by dt plus n square x is 0. You are asked to go this way. Okay. How you go? Let us name this first. we differentiate this, differentiate with respect to x. When you differentiate this not with respect to x, sorry, it is with respect to t, because our independent variable is t. You get dx by dt. Here use the product rule, derivative of this a plus bt with respect to t. A derivative, additive constant, it is 0. Derivative of bt, p is multiple constant, it will survive. Derivative of t with respect to t is 1. So it is only b e raised power minus nt. Then plus a plus bt as it is. Derivative of this e raised power minus nt as it is. Differentiation of power with respect to t minus n. Then log of e to the base e, it is 1. You know. Well, this gives you dx by dt is your b e raised power minus n nt, it is minus nt, then minus n times a plus bt e raised power minus nt. Do you follow me? Well, you can write this is your, or you can replace by this dx by dt is this a plus bnt e raised power nt. Well, this is your a plus bt e raised power nt, this one. I will use here first, using first. What is a plus bt e raised power minus nt? It is x. But use it. It is dx by dt is b e raised power minus nt minus nx. Differentiate this setup again. Differentiate again with respect to x. What you get, you just see what you get. It is d2x by dt square is equal to, here b derivative of e raised power nt, e raised power minus nt as it is. Derivative of power, it is minus n, log of base, it is 1. I will name it second. Then minus n, derivative of x with respect to what? T. It is dx by dt. Dx by dt. Well, you are getting d2x by dt square is minus bn e raised power minus nt minus n dx by dt. Now we want to use the value of what? E raised power minus nt. You don't have here e raised power minus nt. You can use it. Dx by dt we need. Now from second I will write, using second. By equation number second, you see how I get bn, where I am having b e raised power minus nt. Why I am doing so? Because in the result I don't have e raised power minus nt. It is eliminated. So how I eliminated? I can get its value from second, then use it here. I can write b e raised power minus nt is here. It is equal to dx by dt plus nx. Be cautious. I am getting b e raised power nt from this. Then use here. It is d2x by dt square is equal to minus n. Your b e raised power minus nt. B e raised power minus nt is given by this. It is dx by dt plus nx minus n dx by dt. Just to simplify this, one step more. This is your d2x by dt square is equal to minus n dx by dt minus n square x minus n dx by dt. Now this is twice. When you take it here, it is d2x by dt square plus 2n dx by dt plus n square x is equal to 0. This gives you the correct result. So this problem also gets solved. Now there is one more typical problem that I want to share. I will rub it. Just look here. It is your problem 4. It is if y is given by e raised power minus kx by 2, then a times cos of nx plus b sine of nx. You are asked to prove what you have to prove. You have to prove d2y dx square plus k times dy by dx plus n square 1 by 4 k square y is 0. You can name this first. We differentiate this with respect to x. Treating product rule, we have to go by product rule. This is dy by dx. Okay. Now derivative of this exponential function as it is, e raised power minus kx by 2. Then differentiation of power of the exponent, that is x का आएगा 1 और minus k by 2 is here because derivative of x है 1. Then second function आप इसी तरह लिखेंगे a cos nx plus b sin nx. Then plus right first function e raised power minus kx by 2. Derivative of this, derivative of cos क्या है minus sin. Angle derivative nx का n. So it is minus a n sin nx. इसी तरह यहाँ पर भी derivative of sin cos angle में है nx, उसका derivative आएगा n. So it is plus b n cos nx. Well, you see here it is dy by dx. I will just simplify this. Now this e raised power minus kx by 2 into a cos nx plus b sin nx. E raised power minus x by 2 a cos nx b, it is y. Using first, I will simply write it minus k by 2y because of this product. Then this is plus e raised power minus kx by 2 minus a n sin nx plus b n cos nx. Name this equation second. There are two ways of solving this problem. One is to find directly this relation. Find directly this relation. Second way is to first evaluate d2y dx square. You have already evaluated dy by dx and you have y. Use these three values in this equation. You will get left side is equal to right side. This is one way. And second is sometimes you get the relation directly. Why directly? Because when I am using e raised power minus kx by 2 into this value y, then I differentiate this. It seems that we are getting something directly. Now differentiate again. Differentiate again with respect to x. We differentiate again with respect. It is your d2y dx square. Then it is constant minus k by 2. Derivative of y is dy by dx. Here we will go by product rule. Be cautious. It is exponential function e raised power minus kx by 2 as it is differentiation of power with respect to x is minus k by 2. Second function you will write minus a n sin nx plus b n cos nx. Be cautious now. Then plus first function as it is minus kx by 2. I am using product rule. Now derivative of this साइन का डेरिवेटिव आएगा कॉस, इसमें एंगल में एन एक्स है, उसका डेरिवेटिव है एन, तो ये आएगा माइनस ए एन स्क्वायर कॉस ऑफ एन एक्स. यहाँ आए डेरिवेटिव ऑफ कॉस है माइनस साइन, एंगल में है एन एक्स, उसका डेरिवेटिव एन, ये आएगा माइनस बी एन स्क्वायर sine of nx. Now you see how we go. I will come here again. This is your d2y dx square is equal to minus k by 2 dy by dx minus k by 2. It is e raised power minus kx by 2 minus an sine nx plus bn cos nx. Take minus common, take n square common. It is minus n square e raised power minus kx by 2 a cos nx plus b sin nx. Now this is again equal to y. By first this is y. You see how we go. Now we use its value as y. Where we reach? Well, it is your d2y by dx square is equal to minus k by 2 dy by dx minus it is k by 2 e raised power minus kx by 2 into this minus an sine of nx plus bn cos of nx. This is your minus n square y, because e raised power minus kx by 2 a cos nx plus b sin nx is your y by using first. Now I can write from second equation. I can write here from second equation, from equation number second. It is this, where I get this thing. I need now this one. I want to find out this value, because I have already told you we can go by direct. This is e raised power minus kx by 2 minus an sine of nx plus bn cos of nx. What is this now? It is dy by dx. It is dy by dx plus k by 2y. So I will replace this by e raised power minus kx by 2 dy by dx plus k by 2y. I don't need this now. I will rub it. Now this is your, just look now, d2y dx square is equal to minus k by 2 dy by dx minus k by 2 here. This is the value from this, dy by dx plus k by 2y. I have to now simplify this. Just look, it is d2y dx square, it is here n square y. I'm sorry, I have forgotten this, right? It is n square y is here, n square y. Well, simplify this now. d2y by dx square is equal to minus k by 2 dy by dx, then again minus k by 2 dy by dx, then minus k square by 4y plus and minus n square y. We have to now simplify this. Now connecting these two, when you connect these two, what you get? d2y by dx square is equal to minus k by 2 plus k by 2 dy by dx. Then here take minus common, it is k square by 4 plus n square y. So transposing this to this side, you get the required result. You get now d2y by dx square is k by, it is minus k times dy by dx minus n square plus 1 by 4 k square y. This is what you want to prove.
plus k dy by dx plus n square plus 1 by 4 k square y is 0. This is this result.